What's up, everyone? It's Calc time with Miss Wesley. We are on our second day of talking about taking integrals using the technique of integration by parts. So I'm looking at integration by parts packet page 3, around right where we should have left off, number 4 that I see here, integral of x e to the 2x. So while you're getting ready to take some notes, a little joke to start things off, get the ball rolling. What do you call a fake noodle? You might call it an impasta. I wrote down IBP is going to be my abbreviation for integration by parts. I wrote down the formula that we hopefully talked about the other day. It's the integral of u dv. If we can scoop up part of this integrand and call it u, and then part of the other part of this integrand and call it dv, make those choices, we'll be able to plug into this convenient formula to be able to find the integral. Since there is no other product rule for integration, this kind of serves like a product rule. So we've got those two important decisions to make first. We have to pick which part of this, x or e to the 2x, is going to be better served here in the u spot, and which one we should call dv. We got to think about some suggestions of how we make those choices. So generally, we choose u to be something where it gets simpler when you differentiate it. I like the choice of x. I feel like when I take the derivative du dx of x, I just get something simpler. I just get the number 1. Versus e to the 2x. E to the 2x is a little bit more complicated, and while it does fit a bit basic integration rule, which is going to be good for us, it doesn't really get simpler by taking a derivative, just like x would. So you make those two choices. Another thing I snuck in here is that when you make the dv choice, don't forget to include the dx from the original integrand. We have dv is all of this, and we have u is that first part. So I jumped ahead. Part of the side work is kind of like similar to u substitution. We take a derivative off to the side. So we say du dx equals 1, and we want to solve that for du. That would mean du equals dx. And in a second, we're going to need both of these things when we plug back into the formula. Then, unlike u substitution, part of the side work is actually integrating both sides. We're going to take an antiderivative of both sides of this. So you're taking the integral of 1 with respect to v should just give you the variable v. And what's the integral of e to the 2x? Well, it is its own integral, as long as we compensate for the fact that we have that 2 in there. The inside derivative of 2 needs to get divided off. If this part is a little bit tricky, think back to a rule that we sometimes go back to. It's anytime you're integrating e to the kx with respect to x, we can just write e to the kx, we can divide by k, that's what the rule says, and don't forget the plus c. Now it may feel like I forgot a plus c here, but generally with integration by parts, we're going to save that for the end. At the very end, for our final answer, we know this integral is indefinite, so it'll have a plus c. So now it's time to solve. Right? We've already scooped up u and dv. We're going to plug into this part of the integration by parts formula. So first we write uv. That's pretty quick. So u is x, and v is this thing I circled, 1/2 e to the 2x. Okay, next part, minus the integral of v du. So minus the integral of, what is v? 1/2 e to the 2x, and then times du, which is just equal to dx. So here's where we sit. Now I guess it's time to get rid of that other integral sign. Everything we wrote down should be easy to handle. We don't have to change this much. I might just reverse the order of the 1/2 and the x, write the first term like that. And then we're integrating, well, 1/2 stays, that's a constant. E to the 2x, again, is its own integral as long as we deal with that 2, as long as we also apply the rule, which tells us to divide by 2. And at this step, when we've dropped the integral signs, probably a good time to remind ourselves that we do need that plus c on the answer. In final form, we can leave the first term, 1/2 x e to the 2x. We can call this 1 over 2 times 2, so 1/4 e to the 2x, and then don't forget the plus c. Every answer we put for these integrals, what's kind of nice about them all is that you can check them. We could carefully use product rule and take a derivative of all parts of this, and we should get back this original expression. Okay, so it's a method. The more you try it, the more you practice with it, probably the more natural it will seem. So let's try it with number 5. 5 looks a little bit different from the last one. So let's make those choices. To start off with, we need to choose a u. We need to choose part of this to be dv. So we got to think. Which part gets simpler when you differentiate? Would it be the x or would it be the square root of x plus 5? I think just like last time, I think x would be a really good choice for you. It gets so much simpler by differentiation, and I would consider the square root of x plus 5 to be the more complicated part. Don't forget this second part gets the dx with it, technically, notation-wise, and we got to do two things. On the left, same side work as last time. We got to take a derivative of both sides. So du dx still equals 1, and that means du equals dx. So we have these two pieces to the puzzle. On the other side, we got to get used to taking an integral of both sides. This side will just be the integral of 1 dv. So again, you're just going to get the variable v on the left. On the right, you might want to think of this to a power, right? We're going to integrate x plus 5 to the 1/2 power. And this shouldn't be too bad. We can think of it with normal anti-differentiation rules that tell us to take the base and add 1 to the power, so we'll raise it to the 3/2, which works as long as we also divide by that same exponent. So we're also going to divide by 3/2, putting a 2/3 here. Don't sweat two things. Number one, don't worry about an inside derivative to divide off. Inside derivative of x plus 5 is just 1 here, so it doesn't really complicate the matter. We also can leave off the plus c momentarily. We can save that for the end, like we did in the last one. So let's plug in. Here's your integration by parts formula. I'll write it out since we're still kind of getting used to it. So equals uv minus the formula says integral of v du. Okay. And let's write that stuff. Feel free to pause the video here and try to write everything out, plugging these three things in and taking your own antiderivative. And then you could just start up again and see if our work aligns. If you're following along with me, what do I write? uv, so x times v, 2/3 x plus 5 to the 3/2 times the integral of that same v. So that's going to be 2/3 x plus 5 to the 3/2. And then instead of du, I can write dx. Okay, so one more integral to take care of. So we've got this thing where I'll just reorder the first two parts just to look nicer. I'll make it 2/3 x plus 5 to the 3/2. And how about this part? Think of going up a power. So x plus 5, we're taking an integral, so we'll go up to 5/2, which works as long as we take the existing 2/3, the constant that was already there, and we got to multiply by the reciprocal of 5/2, so times 2/5 plus c. So my answer is this. The only thing I would do to make it look better is to subtract what? 2 times 2, so 4/15 would be a better way to write that coefficient. But answer is going to look something like this. So hopefully we're starting to see some similarities in the way these problems work. I want to skip ahead. Can you go skip a couple pages to number 9? So mine appears in my packets, the top of page 5 is number 9. And I want to try one that has a fraction in it, just so that we see something a little bit different. And we still make the same choices to start out with. So you have a 5x, you have an e to the 2x. We have to think of which one would be wise to call u and which one would be smarter to call dv. So what do you think? Which one gets simpler by integration? I feel like the e to the 2x is always the part that's a little bit more complicated. It doesn't really get simpler by integration, but don't forget that it's on the bottom of a fraction. So I'm going to scoop up the 1 over e to the 2x and call that dv. 5x is what I didn't use yet, and 5x is a really good call to just make u because it does get simpler when you take a derivative. So now I've got both parts of this fraction, handled as u and dv. Let's do some side work. So we'll go du dx, the derivative, equals 5. And solving for du, that makes du equal to 5 dx. Okay. Now, integral of both sides over here. So this is the integral of dv, which we know is just v, equals the integral of this e to the 2x that's on the bottom of the fraction. We'll have an easier time if we swing it to the top and write it to a negative power. We'll call that the integral of e to the negative 2x taken with respect to x. So here we apply that same rule. It is its own integral, e to a power, as long as we don't forget to divide by that power. So we'll divide off by that inside derivative of -2. So I believe these three things, I'm kind of crossing out the 5x here, didn't mean to do that. These three things that I guess I'm starring here are what we're going to use when we plug back into the integration by parts formula. Here goes. Integral of u dv equals uv minus the integral of v du. Great spot to pause and try the plug-in on your own. If you're still going with me, I'll try to put the expressions in the right spots. So what is u? U is 5x, v is -1/2 e to the -2x. Okay. Minus integral of v du. So here goes. V is -1/2 e to the -2x, and then du is 5 dx. Okay. Let's rewrite a little bit. So this thing, you don't really want the constants separate from each other. So we can multiply the 5 and the -1/2 to get -5 halves. And it's x e to the -2x. Okay. Plus, right, I see a minus a negative, so that's probably easier said as a plus. 5 times a half, so 5 halves, combining these constants. Integral of e to the -2x, taken with respect to x. So now we integrate, right? Leave the first term, so -5 halves, x e to the -2x. Here comes another 5 halves, right? That's this coefficient. Then e to the -2x, we've said this all along, is its own antiderivative, and will compensate for that inside derivative of -2 by dividing off. So 1 over -2, not forgetting the plus c. Again, this is your solution. I would probably change this so that it appears a little bit simpler. We could call it -5 over 2 times 2, -5/4. Okay, 10 looks interesting too. Let's try this one. So 10, let's at least get through this setup here. We want to choose something for u and something for dv, but it may be surprising. And I say surprising because in general, we're usually picking the more complicated part to be dv, which I would think would be that ln. Seems much more complicated than x to the 5th. Here's the problem. We don't have a simple integration rule for ln. Anytime you see an ln in the problem, you need to pick it to be your u because we do know how to take a derivative of ln. So we'll put the ln over here this time. That leaves the x to the 5th and the dx to go with the dv. So you've got du dx. Here comes side work where we take a derivative. And what? Derivative of natural log, we got to think back, is 1 over the argument of the natural log. So 1 over 3x. But chain ruling it, let's take an inside derivative, and that's going to be 3. So this should just be du dx with those 3's canceling equals 1 over x. And we'll solve that for du, right? Let's cross multiply. X du equals dx, and du equals dx over x. Let's circle that because we'll need that later, and we'll need this as well. Okay, over to the other part of the side work. Integral of both sides. Integral of dv should just be v because it's like saying integral of 1. And for this part, we know to go up a power, right? X to the 6 over 6, and we'll save the plus c for later. Okay, time to plug in. So you've got integral is uv minus integral of v du. So what is uv? U is ln of 3x. V is x to the 6 over 6. Gotta love that bell. Okay, so we've got integral of v du. So v is x to the 6 over 6, getting through this, and then du is dx over x. A few little suggestions so that you can try and finish this. Not much to do here. I'll just change the order. And just before you take an integral, don't forget to reduce this by a power of x. You're actually taking the integral of x to the 5th over 6. So can we squeeze it in? We go up a power, x to the 6. It was already over 6. It's going to be joined by another 6 that you put on the bottom, so 36. And don't forget your plus c. Hopefully this whole process is becoming a little bit more natural as you start using the integration by parts formula more and more. Something that's for sure is it lets us take way more integrals than we ever used to be able to without a process like this. All right, have a good day.